Hello, my friends. In this video, we are going to be looking at mathematics and the foundational skills that are necessary for our children to gain a greater understanding of bigger concepts in mathematics as they grow and develop those skills for higher level thinking mathematics. So to begin with, we're going to be looking at patterning. Patterning is one of the very first and most simple ways that we can start implementing math for our children. We can look at patterns in all sorts of things. So some people like to use the calendar, the seasons, the time of year for starting children to understand those patterns. But there are a lot of different ways that we can pattern with our children. And it doesn't take very much effort or very long to see that our children really do pick up on those patterns quite naturally, actually. And they, without us prompting them, will actually start creating patterns and start making those connections on their own. We can, though, foster an environment that will help them be able to develop those skills more quickly and more efficiently by providing different means for them. We can provide little beads for them where they can put them in patterns and they can fill in those pattern gaps, or they can play outside. One of the greatest parts of having an environment is that you can go outside in nature and find patterns everywhere. So recognizing patterns is really, really quite a powerful tool in order for your children to create those critical thinking skills that are necessary for mathematics later on in their mathematic career. So patterns is the first thing that we really want to look at, and helping them foster that activity time by putting those connections and putting things together with patterns. Now, the funny thing about patterns is that we can pull patterns out and we can actually connect it into the science world. So a lot of things with mathematics, you'll find that really are connected with other things other than just mathematics. For whatever reason, someone thought it was a really good idea to pull all of these different ideas and concepts together and throw them in a math book and call it mathematic curriculum. When in reality, what we're really teaching our kids is how to engage in the environment, which is a lot of the sciences, and we're also engaging them in our economics. So outside of the natural environment, we're asking them to participate in our everyday environment, right? Where we need to know time, we need to know measurements, we need to know all of these other things economically, like money and finances. I have measurements, shape, time, all of those things. And then we also have the environment on the outside too, the natural environment that is saying, hey, look at all these patterns, look at all this other stuff, and start making these connections. So really, mathematics is more a form of science. So if you teach science with your math, that helps our children be able to connect some of these things a little bit better that they wouldn't normally, they would have to reach and try to figure out those connections. They can, and we have for years, but when we have the environment available and we're thinking in scientific terms, sometimes the mathematics can become a little bit easier for kids because it's something that they can literally touch and feel and something that they can literally experience. So that's something to think about as you're teaching math. Maybe it's not a great idea to do it right out of a textbook. And maybe for your children and for your philosophy, it might be a good idea to expand beyond the textbook and to go out into the environment and actually experience mathematics for themselves so they can make those connections more deeply. So with that, I know that that was a rabbit hole. I went off for a minute on that, but let's go back. So we have our patterns, and those patterns can be found anywhere and everywhere, all around us, every single day. So it really isn't very difficult to introduce our children to patterns. And it's not very difficult for them to pick up on those patterns themselves. The next thing that I want to talk about is how we gain that number sense, how we understand what a number means. And one of the best ways I found to introduce numbers to my children is obviously the normal and natural ways, right? We count with our children, but and that really helps actually. But if we want to do a little bit more, one of the other things that I have really enjoyed are the dot cards. These dot cards you can find online. You can make your own. These I found at childfirst.com, which is the number one, not the name. So child number one, st.com. And these are great little resources to have. The reason why is that our children can look at these numbers and they can start seeing patterns with what the number looks like. This creates new connections in their neural psyche, like in their brain, which is really quite phenomenal. And they'll pick up on these really, really quickly, actually, because we like patterns. We like to see patterns. So these number patterns are really a good way to start getting your child introduced to numbers and what that number really looks like. The other concept is a pyramid concept. I'm going to put those down. A pyramid concept, which looks like this. So same idea. Do you see how when we look at patterns, we can start seeing number patterns within a pyramid? This is powerful. Our brain works in patterns. So when we flip these numbers, our children start recognizing patterns and amounts with an actual number name. And there's that quick connection with them. Now, the other cool thing, I'm just going to add this too, there are bars that you can get as well, where you have like little blocks that are colored in, and those work great too. Anything to visually see what the representation of that number is within a 10 block period, or even by itself works good. And then to put it in a 10 block period, because our math is based on base 10, right? We go to 10 and then it's repeated. So base 10 anything is going to be really helpful. I have seen the bar cards where they go up to 20, which is also very helpful. Once we understand base 10, we can move into those cards that have 20 bars on them. And that helps our children recognize where that number stands within that range of numbers, I guess, if that makes sense. So we're looking at this card right here, and we see that there's a 2 here, which represents the number 2. And then on the opposite end, we're going to see all of the holes, right? Now, this is the next step to doing numbers. First, we want to understand the patterns. I should just look at these cards up here by me. We should understand the patterning and what those numbers look like. And then we should take those patterns and look at them in our base system, which is base 10. Off of base 10, we can see how much number 2 really fills in, right? We can see if it's a small number or a big number, a small amount or a large amount. And we start comparing and contrasting these patterns. This is so, so good and so vital for our children to understand. The next part of this is, after understanding these things, to go to our base 10 buddies. That's what I call them. Other people may call them something else, but I've always called them our 10 buddies. 10 buddies are simply the number that makes up 10, or the 2 numbers that make up 10. So now we're not only going to be looking at the 2 here, right there, we're also going to be looking at what's left over and what patterns create a base 10. There are a lot of really good reasons for why we want to do this. But if you look at this, we have 2 and 8 automatically, right? We know that if there's 2, there's also 8 of something else that fills the gap. If we have 9, there's 1 that fills the gap, so on and so forth. So we can flip through these cards. Just having your children understand and know these cards is going to help them dramatically learning how to add and subtract big numbers, multiply and divide big things. So this is setting up the system in their head visually, so they can visually see what these numbers are doing and why they're connected together. So all of these numbers are connected. The connection is what we want to get to. So we've talked about the patterns. Now we want to connect it with something valuable or something important beyond just a pattern. When we take this, I have a pattern board here. These blocks don't stay in, so I just am going to show you the board and what this looks like. This is a base 10 board. Okay. Now, the power behind a base 10 board is that when you add these numbers together, they are all going to create 10. Okay. So we have, I don't know if you can see that. So we have 4 and 6, and then we get to 5 and 5, 6 and 4. They flip, right? Because we have 1, 2, 3, 4, 5, 6, 7, but they're going to be buddies opposite. So eventually we're going to have our 4 down here and our 6 over here. So these are base 10 buddies. I call them 10 buddies. If you have your children understand the base 10 system and they understand what numbers are added together to equal 10, your life in teaching them mathematics is going to be a whole lot easier, and their life is going to be easier too, because when they see and they connect these patterns together, what happens is when they're adding numbers in their mind, or when they're adding numbers outside of their mind or on paper, wherever they're adding, they are going to see the 10 patterns. What is so powerful about the 10 patterns? If I add 6 and 5, I know that 6 and 4 is 10, and I just add 1 more. The patterns go beyond our ability to even fathom. There are so many different ways that we can connect these patterns together, and they become incredibly useful for our children to start making connections with addition. So when they add bigger numbers like 21 and 19, they know that 1 and 9 are buddies, and that adds up to a 10. So do you see what I'm saying here? This is powerful. So if you can get your children to understand this pattern, and then you can get your children or help your children understand these patterns so that they can add these numbers, it's going to be so powerful for them. This is where you want to start with the foundations of number for mathematics. When we are done with understanding and your children understand your base 10 numbers, then it is invaluable to help them understand the doubles. Your doubles are going to be 6 plus 6, 5 plus 5, 4 plus 4, all of those doubles. If you have your base 10s and your doubles, your children will be able to add, multiply, subtract, and divide numbers so much easier. So please put this as part of your foundation. Even if your children are in the 8th grade, go back and help them memorize. They don't even have to memorize them. They figure it out. They create those patterns and they learn those patterns within this system. If they understand these patterns, I cannot express it enough. Mathematics is going to be so much easier for them and for you. You're not going to be stressing about memorizing a lot of addition facts, subtraction facts. You don't even have to worry or stress as much about memorizing multiplication and division for your children because they see the pattern. They will see the pattern. They'll pick up on the patterns. If we build the foundation for them, they will find the patterns in these things. So really great tools for you to understand and great foundation for you to build upon. After that patterning comes all of the other things where we start multiplying, dividing, and then we start bringing in the decimal system, right? And we start looking at our different, where we're looking at the tens, the hundreds, the ones, and all of those place value systems. That comes in a little bit later. After these things are learned, then you'll want to bring in the 10 patterns. So here we have the 10 cubes. You guys have seen these, I'm sure, right? Where we show how the tens place values work. That is the next step to all of this, is understanding the place values. And after those place values are understood, we don't initially bring in the decimal because that's parts and that's a little bit later, but we do bring in the ones, tens, and hundreds so that we can talk about what happens to those tens and we can show that process of how the 10 ones can become 110, and then the 10 tens can become 100, and so on and so forth. The visual aspect of this is very, very helpful to children, especially if they struggle with mathematics. If they struggle with math, it's because they can't see it, because they can't touch it, and because they don't experience it. They haven't experienced the process yet. These things will help them be able to experience it more. So then we can move on to the tens. After we do that, then we can definitely add in decimals, but we can use other different things to add in decimals. Decimals can be really confusing for kids. So it's important and valuable to take that next step where you just set this aside and you take those next steps and you talk about parts and pieces. If a decimal shows up as a part and a piece of something, it seems to make a little bit more sense, especially if you can connect it to something like money, something that we use every single day, and express to them all the parts and pieces of a dollar. If it's 1/10, then that's what it means. It's like 1/100th is a penny, right? 10 cents is a tenth. And you can look at it in terms of money, and that will really help your children be able to connect the decimal system. Another thing to that I want to add is going into fractions and percentages. It's really cool to be able to do decimals, fractions, and percentages at the same time because they're all the same. They're just different ways of writing them. So if you get your children to understand how those transfer in the percentages and the decimals and the fractions, they'll be able to start understanding those things that are really hard concepts for kids to grasp, but they'll get it. And one of the ways that I've done this, and I want to share this with you just because it's a different way of looking at it, is by using shapes. So shapes are all around us. And while you're working on numbers, you're going to be probably working on shapes because that's in our surrounding and they need to know their shapes and they can pick out shapes anywhere they go in this world and find those shapes. That's making patterns and connections as well. So we're working with shapes with our children. Once they understand those shapes a little bit more, I have my shape box here, then we can take these shapes and we can show them parts and pieces to shapes to help them gain a better understanding of fractions. When we look at the shapes, we can start stacking shapes together. Now, a lot of this can even be done in play before you even have a conversation with them about shapes. They play with these all the time and they build things all the time. They're making connections as they're building, but something else that they're doing is building experience. And the experience is what's going to help them have a greater understanding and conceptualize what we're going to be talking about when we start splitting shapes in half or even into little smaller pieces, right? So one of the ways that we have worked with fractions is by taking the shapes and splitting them into parts and pieces where we say we have one of these and we have two of these that equal one. And so that might be a good idea and a good venture for you. Playing with shapes is going to help expand your child's understanding of mathematics, especially when we hop into the science side of things and we're taking measurements and we're doing all of those other things with shapes. To have their hands on shapes is invaluable. Get blocks, get these shapes. You guys have seen these, right? Get a set of these shapes and let your children play with them often. When they want to play games or put puzzles together, have them create pictures, because the more they touch, the more they can conceptualize what is happening with these pieces. Okay, so experience is incredibly valuable. We talked about time with economics, money. We talked about measurements and shapes and the parts of the whole. All of these things are the foundational pieces of mathematics. These are what's important. These things that I've shared with you are the important components of math. Now, I know that you're thinking, yeah, Heather, but when my child goes to test out of high school, they're not going to ask them these simple questions, are they? No, of course not. And there are ways that we can improve or build upon those mathematics skills. But I'm going to fill you in on a little secret. It's interesting because my child is really, really into physics. He loves learning about the world around him. And what's fascinating is some of those physics concepts have come because of his experiences. And we've been able to talk about those physics formulas, which are advanced formulas, and he's able to understand them because of his foundation that he has. We didn't take him through a textbook, but it all comes naturally through experience and through working with these things in nature or around us. If you want your child to have a greater understanding of those things, and you don't want to kind of make it more of a natural thing, and you want to be sure that they're understanding these things before they leave, you can always get a textbook and a curriculum. If you are looking at making sure all of those things are set so that they can test, and you want to make sure everything is touched on, my advice and suggestion, if you're looking for text, is going to be Saxon Mathematics. And Saxon is, it's been redone, right? It's part of Common Core right now. So if you go to Saxon and you get Common Core Saxon, it's not the same thing as what we grew up in or what we grew up with and how we learned. So if you're going to go that direction and you really feel more confident, or you feel like that will bring you confidence in teaching your children math, you will want to find Saxon Math that has been published before 2000. So before 2000, you want to find your textbooks before 2000. Anything after 2000, as far as publishing dates, they are going to be filled with Common Core math, and it's going to be confusing to your kids and confusing to you to teach it. So go back farther than 2020 or 2000. Go back farther than 2000 if you're going to buy text for mathematics. In these textbooks, the reason why this is highly, highly like on my very top list of math curriculum is because if you've never used Saxon before, it will take you through with each of the chapters. It explains everything. It lays it all out, and then it walks through problems with your children. And then it has practice problems that will be focused specifically on what that chapter is talking about. And then the rest of the lesson is going to be a mix of all the things that they've learned prior to this section. So they're always constantly getting a review. This is why I like Saxon. If you get into the older books, I do believe Algebra 2 has it, maybe. I just grabbed one. Yeah. So algebra, I believe it's Algebra 1 and higher will have the odd answers in the back of the book. So you don't necessarily need the teacher's book as well to get all of the answers. because eventually, because it reviews so often, you're going to have problems throughout the whole entire set or the whole entire book that's going to reach everything because it reviews all the time, is what I'm saying. So if your child only does the odd numbers, they're not missing like anything with Saxon. Okay, so in the back, it will show the problem set and then the answers. There we go, the answers to that problem set. And then obviously, once again, it shows how to do those problems at the beginning of the chapter. So if you're one of those parents that's like, oh, math kind of scares me and I don't want to go on my own with math, I don't want to build my own curriculum, this is my suggestion and my advice to you. After doing the cards and after your children understand the 10 buddies, the doubles, and the place values. After that, then dive into these textbooks because they're going to do great in them. Okay, the other thing is if you don't want to do text and you want to kind of just build the mathematics ideas and concepts around everyday living, that's great. I know a lot of people who do that successfully. And like I said, it just your children, if you're teaching towards your children, then, I had a son who really loves physics. And so we went the physics route. I have a daughter who just loves math and numbers and finances. And so we went that route. So you can gauge like where your children are going to go. And then you don't have to teach them all of the books. Like my daughter, she doesn't really get into calculus. She doesn't really get into physics. So that's okay. She doesn't need to really understand that to survive in this world. But there are other things that she does. And those are the foundational things that I shared with you today that your children really do need to understand because they're a part of our everyday life. There is one other thing that just came to my mind that I will share with you, and that is the concept of equations. I know I'm jumping back a little bit, but this is really powerful to understand too. For the longest time, I had no idea why I was even doing equations. And then, of course, as I'm teaching my children, it pops into my head, oh, wait a minute. Equal means equal. I'm just trying to make both sides equal. That's really what we're doing with mathematical equations. So one of the concepts that is really helpful is, and you can even do it with shapes. I'm grabbing a few shapes like this, where we have the red ones and yellow ones. It's easier to hold. So that's why I'm choosing these, where we have an equal sign in between them. So really, this is patterning. It really is patterning and understanding the concept of what that equal sign means. Because when we get into algebra, we want our children to understand all you're really doing is balancing the equation. All you're doing is balancing it from one side to the other with an equal sign between it. And that looks a lot different. And sometimes the look of algebraic equations can really be intimidating for kids. And so when we help them understand that, no, it's not intimidating, all you're really doing is making both sides equal to each other or finding what they equal. And that has been a really helpful concept. So I wanted to pass that on to you. You can start doing equations with balances. So get some balances. I started doing equations with my kids and they had to figure out those equations when they were really little, even preschool age, because really all it is observation and patterning. We're teaching them how to understand these things around them, the world around them, and how objects connect and interact with each other. Some other ideas for higher level math include a lot of logic. So as your children get into the higher levels, they're really going to be looking more at logic, which is like the physics and just the logics or the logistics of shapes and angles and things like that. One of the resources that I have found to be really helpful is called Euclid's Elements. This is something that actually, I know this is a really random thought, but Abraham Lincoln used it to study math because I think before he became president, or right as he was trying to run for president, because he didn't have an understanding of mathematics very well. So he used Euclid's propositions to help him gain that understanding of it. And really the propositions are there to help build logic, which is really quite cool. And I've really enjoyed doing it with my kids. So the workbook is called The Bones. So the Bones book, and then you could get Euclid's Elements, but all of the elements are listed. And then the propositions, this is just the workbook of Euclid. So, but I'm pretty sure, yeah. So even in the workbook, The Bones, Euclid's Elements are posted, the definitions are all posted, and then there's information in those as well that help children just with their logic. And another thing with the Euclid's Elements is that I wasn't sure if I could really teach it because it's such a different concept than how we were taught growing up. And so I looked it up online, and there are a few channels that actually will go through each individual element in this book. So if you need help, there is stuff online that will help support you through going through the whole all of the propositions in this book, which is really quite awesome. The other thing that I found that I think is kind of a fun treasure for my kids, I told you my son is kind of into physics, and I'm like, blah, physics. I don't know if I remember any of those formulas because high school was a long time ago. But physics, this book was really cool. I really enjoyed it. I'm trying to get the glare off of it there. So Basic Physics by Carl F. Kahn. If you can, I'll post it probably down below, and I'll add it to my resource list because I've really enjoyed that book with my son. It goes through it. Actually, it's pretty easy to follow, I feel. So those are some ideas for you if you're getting into some of the older math and you need some resources for your kids. And fun things to do. I think the Bones book is really fun. It's different, and same with the Basic Physics book. So there you go. There's some other ideas to help with the higher levels of math. There's a lot to mathematics. Feel free to ask questions after this video or to add some of your ideas and concepts. There is a list of math resources that you can purchase and buy for yourself. The other resource, that's what I was going to mention. The other resource that I wanted to mention is online. You can type in math worksheets, and there are some great math worksheets online that you can just download. And I believe it's in the math sheet that I have for you as far as resources, the specific website, but I think it's called mathdrills.com. And you can go in and you could do any level, regardless of age, from kindergarten, pre-kindergarten even, all the way into college or high school math. And there's a ton of worksheets in there that you can just print off and practice with your children. So there's some ideas for you, but the greatest thing that I hope you get from this subject training is those important principles, those important foundational pieces that your child will need in order to understand the higher levels of math. So until our next video, happy mathing and carpe diem.